Hello students. In this video I'll try to bring a very important topic on your tips, and that important topic is alcohols, phenols and ethers. So let us start with the preparation of alcohols, but you just remember that you are watching this video only for the purpose of revision, because this video is not dealing with the details of the reaction. So let us try to recall the preparation of the alcohol and a single sentence, a funny sentence, that is, the grill and fry amino acids in the bowl at the high degree. So let us use this sentence. Grignard reagent, fermentation, amino acids, aldehyde and ketones. Hydroboration of alkene and hydration of alkene. So these are the certain reactions which you have to follow to prepare the preparation of alcohols. Let us start with the first one, that is the Grignard reagent. Grignard reagent reacts with the carbonyl compounds to give an additional product. Now this additional product on the further hydrolysis gives the alcohol. As you can see here, if we are taking here formaldehyde, the alcohol will be primary. If we are taking here any other aldehyde, alcohol will be secondary. And if we are taking here ketone, that time the alcohol formed will be the tertiary alcohol. So this is about Grignard reagent. The next reaction is fermentation reaction. In fermentation reaction, sugars can be converted into the alcohol and carbon dioxide in the presence of yeast. Yeast is containing enzymes like invertase and zymase, and this particular reaction takes place at the 30 degrees Celsius in the dark. Next is amino acid. Amino acids react with nitrous acid to give alcohol, nitrogen and water. Let me tell you, let me make it easy for you. Amines will break down in this manner, and HNO2 you can learn as O no. So this is ROH, alcohol is formed. This is N2, nitrogen is formed, and this is water. Next reaction is acid, aldehyde and ketone. This aldehyde, ketone or acid can be easily converted into the alcohols by the reduction reaction. Aldehyde, ketone or acid can be easily converted into the alcohols by using the different reducing agent. These reducing agent may be lithium aluminium hydride, lithium borohydride, sodium ethoxide, etc. When the reduction is done by using sodium ethoxide, the reaction is also known as Bowen-Blank reaction. Next kind of reaction, and very important reaction, is hydroboration of alkene. In hydroboration reaction, diborane is added to the alkenes to give a product which further on hydrolysis in the presence of H2O2 gives alcohol. This reaction is very important just because it follows anti-Markovnikov law, according to which here this H will be BH3 ka H will be added to the carbon where the hydrogen is in the less amount, and the BH2 will be added to the another part, and this H one by one will be replaced, and further you will be getting this compound which on the further hydrolysis gives you alcohol. The next reaction is hydration of alkene, and this is very simple reaction, and this is CH2 double bond CH2. In this particular reaction, alkenes are added to the water in the presence of concentrated H2SO4, which work as a dehydrating agent here, in this particular reaction, water is added to the alkene in the presence of concentrated H2SO4. Here this concentrated H2SO4 is working as a reagent, is as a catalyst for the reaction, and it gives alcohol. So let us talk about the properties of alcohols. Students, properties of alcohols we can easily understand by understanding how the bonds are breaking down in the alcohols. So let us see how the bonds are breaking in the different reactions in the alcohols. Here I am taking ROH and it will work, no bond will be broken down, and this ROH will be entirely converted into the another kind of products. Here in this we will see that the alcohols are breaking down in the way so that they will release the H part, yani the O and H will be, the bond will be broken down, will be O and H. The another part, another kind of breaking will be the between the R part and the OH part. So here you can see the OH entirely will be removed and another kind of group will be attached to the R part. So we will be studying the properties of alcohols only in this manner, that is how they split to give out the reactions, whether it is working as a whole or it is releasing H or it is releasing OH. So let us take the first kind of reaction, and that is ROH. This is a very simple one, and we will find the only two reactions where the alcohol work as a whole, and that is dehydration and oxidation. In dehydration reaction, alcohols can be dehydrated in the presence of concentrated H2SO4. This concentrated H2SO4 is a dehydrating agent and releases water molecule to form the alkene. In another kind of reaction called oxidation reaction, we can easily convert alcohols into aldehyde ketones or acid. In another kind of reactions called oxidation reaction, we can easily convert the alcohols into acids, and this reaction takes place in the presence of oxidizing agents like alkaline KMnO4 or acidified K2Cr2O7. So alcohols can be easily converted into acids by using the oxidizing agents like alkaline KMnO4 or acidified K2Cr2O7. Let us talk about the another kind of reaction where the H will be released. We can recall all kind of reactions of this kind where the H is released by using the term called game, where the G will remind us for the Grignard reagent, that is the reaction with the Grignard reagent, and A will remind us for the acid, and Me will remind us for the metal. So let us talk about the reaction of alcohol with the Grignard reagent. In this particular reaction, as you can see here, that ROH will be broken down to release H, and this H, which is H plus, is going to react with the minus part of the RMgX, and this will form alkene. So this is RH, alkene will be formed, and the another part will be attached to form the another product for this reaction. The another reaction which we have to see here is the reaction of alcohol with the acid. This reaction is very common just because you have done it in the 10th standard also, and all we know that the reaction alcohol and acids react in the presence of concentrated H2SO4 to give the esters, which are fruity smell containing compound. So this is alcohol reacts with the acid to form ester and water, and reaction takes place in the presence of concentrated H2SO4. Another kind of reaction where the H will be coming out from the alcohol is the reaction of alcohol with the metals. This reaction also indicates that there is release of H from this, and Na will be added to the ethoxide or alkoxide part to give the hydrogen gas. This particular reaction is the reaction which is indicating the acidic behavior of the alcohols. Let us talk about the another kind of breaking, that is where the OH completely will come out from the reaction and the another group will replace the OH. These are the simple reactions where one by one we can understand the reaction of alcohol with the ammonia, reaction of alcohol with anhydrous zinc chloride and HX, which is also known as Lucas reagent, or the reaction of alcohol with SOCl2, or the reaction of alcohol with PCl3 or PCl5. So these are the four reactions which are very important also. That is, whenever we react alcohol with the ammonia, we will get trialkylamine. Whenever we react the alcohol with the zinc chloride and HX or Lucas reagent, it is a very good test for the conformation of primary, secondary and tertiary alcohols also. Primary do not give the precipitate, jabki tertiary and secondary undergo the precipitation formation, and this is the replacement of OH and formation of chlorides, that is RX will be formed. Immediate formation will indicate you the tertiary alcohols. Secondary alcohols will give you the precipitate very slow, like within 4 to 5 minutes, and primary alcohols will not undergo the precipitation reaction. Next reaction is the reaction of alcohol with the SOCl2, which will again give you RCl, and the next reaction is the reaction of alcohol with the PCl3 and PCl5, which will again give you the RCl. In all the reaction you can see that the OH will be replaced by the another part here and here. So we can recall the entire reactions given by the alcohols by using a simple concept, that is where it is working as a whole, dehydration and oxidation, where it is releasing H, which is a game, and where it is replacing the complete OH, which is the simple reaction of the replacement by any of the other group like amine, like chloro, by using the SOCl2, or by using PCl3, or by using PCl5. Okay students, let's move to the another topic, important topic, and that is preparation of phenols. We can recall all the preparatory method of the phenol again by using a funny sentence, and that is abhi kyun kal subah. Start with the aniline starting from the A, and let us see how it happens. Aniline, in the presence of sodium nitrate and HCl, at the very low temperature is converted into the diazonium salt. This diazonium salt is further hydrolyzed in the presence of acid to give the phenols. This reaction is known as diazotization, and diazonium salts can be easily converted into the various organic compounds having ring. Next reaction is reaction from the benzene. So the benzene can be easily converted into the phenol. Benzene can be easily converted into the phenol by oxidizing it in the presence of vanadium pentaoxide. The next reaction is the conversion of cumene into the phenol, and it is very important reaction. Look at the structure of the cumene first, which is also known as the name of the cumene is actually isopropyl benzene. Look at the structure, learn the structure so that it will help you out to recall how the cumene is used to prepare the phenol. So this is isopropyl benzene. Cumene can be converted into phenol. So let us see to the reaction. This isopropyl benzene, known as cumene, is oxidized into an intermediate product which on the further hydrolysis in the acidic medium, it releases this ketone from it and forms the phenol. So just learn the structure of the cumene so that it will help you out to remember the entire reaction. The next reaction is the conversion of chlorobenzene into the phenol, which is a reaction which is given a very important circumstances, very harsh circumstances, because this is a substitution reaction, and substitutions are not easy in case of the aromatic compounds because they are bonded with the double bond, and the double bond is not broken down easily. So this is chlorobenzene, which is added to the sodium hydroxide, or not added actually, it is going to undergo in the substitution reaction. This reaction takes place at the high temperature and at the high pressure. This reaction is also known as Dow's process for the preparation of phenols. The next reaction is benzene sulphonic acid. The benzene sulphonic acid is this SO3H, which is added to the sodium hydroxide or fused with the sodium hydroxide to give you the sodium salt of benzene sulphonic acid, SO3Na, which is further hydrolyzed in the presence of acid to give you phenols. So this is all about the preparatory method of the phenols, and you will always remember it by using the term by funny sentence abhi kyun kal subah. So students, let us talk about the property of the phenols. Properties of phenols can be understood easily by categorizing them into two parts, that is the electrophilic substitution reactions and the named reactions. Basically, electrophilic substitution reactions are very easy just because we are going to direct the coming electrophile to the ortho and para positions only. So let us talk about the bromination and the nitration, which are the most important reaction for the substitution, electrophilic substitution reaction. The first one is bromination. While brominating phenol, we have to remember, or we have to just take care of the conditions in which the phenol is being brominated. That is, if the reaction is done in the presence of the carbon disulfide, or the reaction is being taken place in the presence of water. In both the cases you will be getting the different products, so you have to remember this, and most of the time the questions are asked from this particular topic. That is, when the reaction is done in the presence of the carbon disulfide, you will get the mono-substituted product. Mono-substituted product, and always they will be directing to the ortho and para. So one will be at the ortho and one product will be at the para. And obviously para directing will be the most stable compound, so this will be the major product and this will be the minor product. On the other hand side, if the same bromination is done in the presence of the H2O, and in the water, in the presence of water, you will be getting the tribromophenol, which again will be directed to the three of the positions like ortho and para positions, but this is tribromophenol. This tribromophenol is a white colored precipitate. Another reaction which we have to take care of is the nitration reaction. As in case of the bromination, we took care of that whether the reaction is taking place in the presence of CS2 or in the presence of water. Here we have to take care of whether the reaction is taking place in the presence of dilute HNO3 or it is taking place in the presence of concentrated HNO3. In both the cases, we'll be getting the different products, just like in case of the bromination, that is mono-substituted product or the tri-substituted product. Let us see how. In case of dilute HNO3, you will get the mono-substituted product, and obviously they will be again at the ortho and the para position, and this para will be more stable than the ortho compound or ortho derivative. On the other hand side, if we are doing the same with the concentrated HNO3, we'll get the tri-substituted product, that is ortho and para, but all 1, 2, 3, 4, 5 and 6, that is 2, 4 and 6 trinitrophenol, and this is also known as picric acid. So this is important to remember whether the reaction is taking place in the presence of dilute HNO3 or it is taking place in the presence of concentrated HNO3. In case of concentrated HNO3, you will get the picric acid, and in case of the dilute HNO3, you will get monosubstituted product, yani ortho and para nitrophenols. Now let us talk about the named reactions. The first kind of reaction, named reaction, is Kolbe reaction. During this reaction, phenols react with the sodium hydroxide and carbon dioxide at 4 to 7 atmospheric pressure to give a very important compound called salicylic acid. So this salicylic acid is formed during the Kolbe reaction. The next important reaction is the Riemer-Tiemann reaction. During this reaction, phenols react with the chloroform in the presence of sodium hydroxide at 340 Kelvin to give a product. This, on the further fusion with the sodium hydroxide, give you another addition product where the OH is added by the removal of chlorine. Now this OH, because it cannot be added to the same carbon atom, it splits out to give out the water molecule, and a very important product again, that is salicylaldehyde, is formed. So in the Riemann-Tiemann reaction, salicylaldehyde is formed from the phenol. Another reaction, a named reaction, is Friedel-Crafts reaction. Friedel-Crafts reaction is the alkylation or acylation in the presence of anhydrous aluminium chloride. This is a Lewis acid which facilitates the reactions. So phenols are added to the CH3 group either at the ortho and at the para position to form the cresols. This compound is known as cresol. This is also known as cresol, but this is para-cresol and this is ortho-cresol. And obviously, para-cresols will be more stable. So this is about Friedel-Crafts reaction. Another very important reaction is the oxidation reaction of the phenol. During the oxidation, phenols are converted into the para-benzoquinone in the presence of alkaline KMnO4. This compound is known as para-benzoquinone. I hope we have covered all the alcohols and phenols, the properties and the preparatory methods. And I think that these will be helpful for you for the examination purpose. Good luck.